All right. Podcast 12.1. Rate laws are 0, 1, or 2. Other rate laws are possible, but not in AP chemistry. And 0 is almost never showing up either. We're going to find rate laws using tables. We're going to talk about first order equation, graph of a straight line, half-life. Second order and third order, same thing. You need to know that nuclear is always first order. Reactions proceed at different speeds. I don't think this is anything too crazy. Products, chemists can predict. So if I say Na plus Cl2, you guys with your amazing powers can say NaCl or balance it and do that. Rates, there's not a good way of predicting it. You actually have to try it. Maybe someday someone will be able to look at it and go, oh, this will be faster, but it's not done much. So the only way to determine rate is by experiment. Okay. Some rates are slow, the decay of mummies. Some rates are fast, the explosion of TNT, or any explosion on World of Warcraft. So it's just like how quickly someone can pick up on something. How quickly can Rick Astley learn to sing and dance? Like this. How quickly can Jeff learn to sing and dance? Jeff will never be able to dance until he's 50 years old. And even then, only he will think he can do that. Okay? All right, on this part, what you need to be able to see is this is an elementary step. So elementary means simple. These are the little steps of a reaction. So if I have an overall big reaction, why did it move? If I have an overall big reaction, this would be just one step. The word molecularity isn't used very much. Neither is unimolecular, bimolecular, termolecular. So this part you don't need very much. But if it's just A yields products, notice there's one A in it. The rate law would be rate equals K, which is a constant, times A to the first power. Okay? That means rate is only impacted by A. Does that make sense? If I have A plus A yields products, that means both of these things have to hit and collide, which is why it's squared. You would think it would be doubled. You'd think it would be 2 times as much. It's not. It's squared. Okay? And 2A is the same thing as A plus A. A plus B yields products. Notice 1A, 1B, AB. A plus B yields products. A squared B. So you don't need to write down all of these, but do you get the idea of how you can figure out the rate laws? On that elementary step, if it's an elementary reaction, you just count the occurrences of each reactant. Okay? For a little AA, these are my coefficients. A little BB, these are the coefficients. Okay? The rate equals K to the M, B to the N. Notice they are not coefficients. Now, they might be, but I don't want you to think the coefficient determines that rate. It does not determine the rate. How do you determine those exponents? How do you determine any rate? By experiment. Can you tell that's the trick question? Right? The only way you can determine the rate of a reaction is by experiment. If I tell you that iron rusts very quickly, how fast does tin rust? I don't know. That's the real answer. I don't know. Give me some tin. Let me make it rust. Okay. K is a constant and has units that must be derived. Order for the reaction is the sum of M plus N. Order for a reactant is its specific exponent. That slide right there was pretty much the pod quiz. Okay. So again, the order with respect to A, is M. The order with respect to B is N. The order for the overall reaction, where did those go? Overall reaction, where did that go? Is M plus N. Kyle, would you stop having Mike Snelly take over my computer, please? Are we okay here? Dang, that's fast. You guys sure you're ready? All right. Well, just say no. Don't say yes. I'm happy to. You just want to see me write and have it disappear. Again, A's order is M, which is a number. B's order is N, which is a number. And then the reactions order M plus N. That's not a rate. It's called the order. It implies how much it impacts the rate. So this means that in the rate determining step, in the slowest step, if M equals 1, there's 1A in that reaction. If the rate determining step has 2 A's in it, A would be squared. If the rate determining step had 3 A's in it, 8 would be cubed. If the rate determining step had no A's in it, it would be 0 order. And do you little math geniuses remember what anything to the 0 order is? 1. It also gets rid of units, right? We all set with that? Yep. Yep. And it affects it exponentially. Okay. I'm going to do a bunch of these problems from our worksheet. So that's why I'm skipping from these. Tricks of rate laws. Oh, look, these are the words I wrote before. That's creepy. And I can't erase them. Oh, there you go. Tricks of rate laws. Exponents are not coefficients. This is the second or third time I've said that. Do you think that's the trap question AP Chemistry loves to ask? Yes, it is. How do you figure out exponents? By experiment. And you can use the formation of a product or loss of a reactant to determine the rate. So sometimes what will happen is you'll have the formation of a product, so you'll have something turn purple. There's a iodine-Clack reaction that all at once turns purple. Okay, I did that in Excel. All right, well, other people might have too. Other one is slower, where you look at the lab that we're going to do. You're going to watch colloidal sulfur form, and it basically fogs up like you're really old and getting a cataract until you can't see through a beaker. And we're doing that on Monday. It can also be instead of the formation of a product, it could be the disappearance of it. So I could start off with something colored, and then you could measure how it clears out. You see how we could use a spectrophotometer to do this? So Beer's law, we can see, take measurements over time and see how it changes. Some people hate the math part of it, which we'll go over the math part again on the other things. If the change is nothing, it's 0 order. The change is the same, it's first order. The change is something else, that's second order. We have some people in here every year or two, and you don't need to raise your hands. Like Jeff here is a sophomore, and he's in Algebra 2. I had someone in here in Algebra 2. And if you're in Algebra 2, this is all you need to know because you haven't done a ton with exponents, but you probably have forgotten about it. Then, it's not even Algebra 2 anymore. Advanced Algebra, excuse me. Then all you need to know for AP Chemistry is if you double A and the rate doesn't change, it's 0 order. If you double A and the rate doubles, it's first order. The change is something else, it's second order. So looking at A's change and the rates change, algebraically, it is blank order. Okay. It's exactly the same. I skipped a couple of problems that I wanted to do from the homework packet that you guys have. Okay. Hopefully you can understand the math, and I'll go through the math a little bit more. So if you're afraid that the math will get you once we do that. Okay, so that's what I get for trying to be tricky. What I'm going to look at here, do you see how these are all 0.11111, 0.22222? I didn't want to make you copy this chart down. That's what we're going to do it in class. See how this doubles? If this doubles, now without even looking, so if this doubles, and this doubles, what order would that be? And that's what happens here. It doubles, right? If they both double, that means 2 to some power x equals 2. What power is that? First order, okay? So if they do the same thing, then it's first order, okay? Now, if instead of that, I know this isn't what the numbers show, but if this was, as this doubles, this is 4 times as much, that means 2 to the power x equals 4. What is the exponent? 2. Now, if we did this and 8 times 10 to the negative 4th, and the next try was 8 times 10 to the negative 4th, the change here is what? Times 1. So that would mean 2 to some power x equals 1. What's the exponent for that one? 0. That's it. That's the algebraic part of it. And it depends how fluent you are with exponents. And I want to make sure if you're not, you don't go, oh no, I can't do this. Because you can. Good question. And I don't want to do another one of those. Okay, so I gave you a rate law sheet yesterday. And everything you need to know is on that rate law sheet. So this is also on your equation sheet, except zero order is not on the equation sheet. The reason why it's not on the equation sheet is I believe it was no longer tested on the AP exam. Okay? So if it's zero order, that means it has no effect. The graph of the straight line, now notice this is like y equals mx plus b. Do you see how this is y equals mx plus b form? So the slope is negative k, and that would be the constant. Now, do you really look for a constant if it's got no effect? Not really. But you do need to know the graph of A versus T gives you a straight line plot for zero order. Okay? And then this, honestly, is the amount you started with. And really, no one cares how much you start with. You just want to know what's the rate of reaction. And that just, shoves it one way or the other. The slope would be the same with different starting rates. Zero order half-life. Okay? So A is my original amount, right? If you have to calculate the half-life and you know that the equation for zero order, then this is half, the amount at time t would be half of A naught. So then what happens is A naught, right, if you rearrange these things, half of A naught, right? So if I take A naught and move it over to the other side, I have the half-life, T1 half, equals A naught over 2K. Notice the amount you start with matters. Which is different than what we've done before. When we did nuclear decay, remember we did half-lives before? The half-life was always whatever the half-life was. It doesn't matter how much you have. Okay. So again, on that sheet I gave you yesterday, first order, ln A equals negative kt plus ln A naught, and then it shows you the half-life is ln2 over k. And you can derive that equation by playing with the algebra, or this one is used quite a bit. This is what nuclear, always nuclear, other things too. So if you look at this, do you see how the A naught is not in this equation? Right? If A naught is not in the equation, then the starting amount is irrelevant. Right? The half-life will always be ln2 over k. Yep. Yep. Mm-hmm. Nope. Nope. Just natural log 2. So if you'd like to put 0.693 there instead, you can. Some places do that. But I like to show, you can almost see how this derives without actually deriving it. Some of us can even derive it right now in our heads. Oh, yeah, yeah. Ding. So the graph of a straight line, and this makes sense, if I say y equals mx plus b, do you see how the slope is negative k? And I'm going to graph y is going to be the natural log of a, and t is my x. Make sense? So you can expect multiple choice questions that have, woo, whoa, woo. And then if I told you that this is ln a versus t, then that tells you that it is first order. Yep. For that reaction. Yeah, so each reaction has its own K. And then, so did you pick up that on that sheet that you guys have? It has the integrated rate law for second order, 1 over A versus T. So can you tell the graph is going to be 1 over, whoops, it's going to be 1 over A versus T, right? And if you look, half-life is 1 over K A naught. So that means starting amount impacts half-life. Make sense? So you can fully expect we're analyzing this reaction and we're looking for its order with respect to B, and we find that its half-life is constant no matter the amount. What order is it? It's first order because the half-life is constant. I'm looking for a reaction on its order with respect to C, and as I change the amount, the half-life changes. Could it be zero order? Yes, and that's the same thing that you should expect. There's the same graph we mentioned earlier. So these would be what the graphs would look like. ln of something, 1 over something. What order is this? Second order, because this is the first order check. This is the second order check. First order is ln versus t. Oops. 1 over n versus t. So do you need to have that memorized? Yeah. That's the worst part, is this is getting memorizing these two things. Notice again, coefficients do not equal exponents. That's the trick that's going to be there. And then, it's a joke, at this rate, we'll be here all night.